Hello guys, I'm Mr. TSEBE and welcome to my session, Introduction to Eigenvalues and Eigenvectors. So without any further ado, let's get into the content. Suppose that we are given a matrix. This is the first question, which is A. Matrix A1. And then they want us to find the eigenvectors and the eigenvalues for this matrix. But we know that determinant is the formula that we're going to be using throughout to find the values of the eigenvalues multiplied by identity matrix. This will be 0. So my det, which is determinant of this matrix A1 minus lambda AI, will be the same as 1 minus lambda for 3 minus lambda. Remember, we are subtracting lambda diagonally according to this. So this will be 2 and this will be 0 and 0. So in order for us to find the determinant of this, we are going to take this multiplied by this and this one multiplied by this and subtract it. So it will be 1 minus lambda, 3 minus lambda, minus 2 times 4, which is all 0. So this will be 1 times 3, which will be 3 minus lambda, 3 times lambda minus 3 lambda plus lambda squared minus 8. This is equals to 0. Putting this in a standard form, our lambda squared minus 4 lambda minus 8 plus 3, it's minus 5. And this all goes to 0. So my lambda will be 5 and 1. But if I subtract here and I plus here, then when we expand, we will get this. So my lambda will be minus 1 or my lambda will be 5. So these are the values for lambda. So right now, since we're having the eigenvalues, so let's find eigenvector when lambda equals to minus 1. But the formula will be a minus lambda times I x equals to 0 when lambda equals to minus 1. So we are going to substitute here. It will be a minus 1 because of this is the value of our lambda multiplied by I x equals to this. And this will become a plus I x equals to, but this will be equals to what? It will be equals to our matrix 1. But since here is positive, we are going to be adding by 1 here. So this will be 4, 2, 3, and then we add by 1. We do it diagonally. And this will be xy, which is equals to 0 and 0, according to this formula. So doing this will be 2, 4, 2, and 4 again. So we are going to let x to be 1. And according to this, we are going to be having 2x plus 4y, which is 0. So if I add, this x and y, which is 0 and 0. So if I substitute by 1 here, plus 4y equals to 0. So my 4y is going to be minus 2 over 4 over 4. So my y is going to be minus 1 over 2. So the value of x and y will be 1 and minus 1 over 2. 1 and minus 1 over 2. So when eigenvalue equals to minus 1, eigenvector will be 1 and minus 1 over 2. So let's do it when lambda equals to 5. I'm writing it that side because I don't want to forget it. So when lambda equals to 5, I'm going to substitute again in this equation, which is lambda multiplied by identity matrix of x, which is 0. So if we substitute by 5, it will be 1 minus 5 multiplied by I x, which is this matrix. So it will be 1 minus 5 4 to 3 minus 5. Like this, because of we are subtracting diagonally. And this will be the same as xy, which is 0 and 0. So simplifying this, it will be minus 4 to 4 minus 2. Xy, which is 0 and 0. So we are going to let x to be 1. But we are even this equation. Let's use this one right now. We are going to say this 2x minus 2y equals to 0. So, but my x is 1. I'm substituting. This is 0. So, this will be 2y over 2 over 2. So, my y is going to be 1. Or another one can say, I'm using this first equation. So, it will be minus 4. And then here it will be x minus 4y equals to 0. But what is my x? My x is 1 minus 4y equals to 0. So this will just be the same. Oh, sorry guys, this is positive. So even here it's positive. So this will just be minus 4, and then when this goes to this side, it will be minus 4y. I divide by minus 4 and minus 4. So my y is going to be 1. So the value of my x and y will be the same as 1 and 1. Will be the same as 1 and 1. So let's do another example B. So this is the matrix that we are given, matrix A2. So firstly, we are going to find the determinant, which is A minus lambda multiplied by identity matrix of which is equal to 0. But what is my determinant? My determinant will be A2 this time minus lambda multiplied by I, which is the same as 1 minus lambda, 2, 2, 4 minus lambda, which is the same as 0 and 0. This is what we are having here. So for us to find the determinant, we are saying this multiplied by this and that multiplied by that. And then we subtract. So it will be 1 minus lambda multiplied by 4 minus lambda minus 2 times 2, which is the same as 0. So if I multiply throughout, it will be 4 minus lambda minus 4 lambda plus lambda squared minus 4 equals to 0. So this 4 cancel out this one. So I'll remain with my lambda minus 5 lambda, which is the same as 0. So if I factor this out, I'm going to be having lambda minus 5 equals to 0. So my lambda, it will be 0, or my lambda is going to be 5. So this is the eigenvalues of this matrix. So right now we need to find eigenvectors. But when lambda equals to 0, this is the formula that we are going to be using to find our eigenvectors. And we say this is equals to 0. So if we substitute 0, a minus, this will just give us 0 here, multiplied by x, which is this, which is a multiplied by x. And then this is just our matrix, because of subtracting by 0 doesn't do anything. 2, 2, 4, x, y, which is the same as 0 and 0. Let me record my second eigenvalue, which is 5. So I'm going to let x to be 1. So here I'm going to be having x plus 2y is going to be 0. So if I substitute by 1 here, I'm going to be having 2y, which is 0. So my y will be the same as minus 1 over 2. Even if you use this equation, it will give you the same thing. So my eigenvectors is going to be 1n minus 2 when lambda equals to 0. Let's check when lambda equals to 5. So when my lambda equals to 5, we are going to say when lambda equals to 5, we know that this is the equation that we are going to use. But my lambda this time is 5 multiplied by my identity matrix, which is 0. So, but my A will be minus 5I x, which is the same as 1 minus 5, 2, 2, 4 minus 5. We are multiplying diagonally. Don't forget, guys. This will be x and y, which will just be the same as 0 and 0. We are going to be having something like that. So this will be something like 5I x equals to minus 4, 2, 2, minus 1, x and y, which is the same as 0 and 0. So I'm going to let x to be 1 so that I can find the relationship between x and y. So, but using my first equation, this will be minus 4x plus 2y, which is 1, which is 0, sorry. So if I substitute by 1 here, plus 2y equals to 0. So my 2y is going to be 4. If I divide by 2 here, I'm going to be having y as 2. Even if I use this equation, it should give me the same answer. So x and y will give me something like 1 and 2. If I multiply this one by 1 over 2, I'm going to be having something like 1 over 2. And if I multiply this by 1 over 2, it's going to be 1. So if a person wrote these vectors like this or this way, they are all correct when lambda, when our eigenvalue equals to 5. This is our eigenvectors. Thank you guys for tuning in, and if you like this session, you can subscribe and also share it to your mates and then enjoy. Thank you.